This lesson relates to sampling problems that can occur in reports of statistical data. After completing this lesson, you will be able to identify the following 3 sampling problems in a statistical report. Each of these relate to how or where sampling is taking place, when they're being selected, and who or what the samples are being compared to. I'll discuss each of these in turn. Let's start with a quick brain teaser. If I asked you to estimate the number of jelly beans of each color that are in this jar, how would you go about doing it? Would you toss the whole jar out, separate them into piles, then start counting each set of jelly beans in each pile? You could, but that process would be sure to ruin your entire afternoon. If you said, select a sample of jelly beans and count the number in the sample, then your train of thought would be in line with most statisticians. It is often impossible to gather data from every possible entity in the population. Whether you're working with systems or people, we often need to rely on samples or a segment of the population as a representation of what is happening in the whole population for that variable. This is even seen in medicine, in which doctors take small samples of your blood or urine and use this to make generalizations about all of your blood or urine. Given that samples are used in this way, it is important to ensure that they are representative. Non-representative or misleading samples is the first sampling problem that Joel best describes. It is very rare that we're ever able to count every case. So we want to make every effort to ensure that the sample was not selected in a way that would drastically influence the results. When critically thinking about whether or not a sample is misleading, a key question to ask is, was the method used to sample data biased in any way, or would change in the location of the sample alter the results? To put this in context, let's look at a couple of examples. In early 2006, there was a lot of discussion on the devastating impact of bird flu, otherwise known as H5N1. A statistic that appeared in many news reports was that the bird flu has a death rate of 50%. As you can imagine, this caused several needs for concern, as this figure by far eclipsed the number of people that died from the regular strains of flu. However, on digging deeper into the statistic and practicing some critical thinking, what came to light was that the data for these figures was sampled from individuals in Vietnam and other Asian countries who worked with poultry and therefore had direct exposure to infected birds. For these workers, going to the hospital was a last resort, which means that only the sickest patients were being included in the sample. The figure failed to take into account the individuals that stayed at home and recovered, and individuals in other countries in which healthcare was more accessible. For all of these reasons, the resultant figure was biased by being based on a misleading sample. Another example of the use of misleading samples can be found in the classic polling era that occurred in the 1948 U.S. presidential election. On election night, the Chicago Tribune printed the headline, "Dewey defeats Truman," which turned out to be mistaken. Once again, these results were highly dependent on how the data was sampled. The Tribune collected their data by conducting a phone survey and asking the individuals in the household who they were voting for. By a landslide, they got an overwhelming response in favor of Dewey, the Republican candidate, winning the election. However, the problem here was that most people that had phones in the 1940s were pretty well off and more likely to vote for the Republican candidate. The Tribune's sample failed to include the common man, and its resultant statistics were therefore based on a misleading sample. The second sampling problem discussed by Joel Bess relates to the use of convenient timeframes. Unlike misleading samples, which refers to problems with how or where sampling is taking place, convenient timeframes refers to problems with when sampling is taking place. Oftentimes, statistical reports include figures that make an effect seem larger than it really is by strategically selecting a specific time frame. Joel Bess discussed the problem of convenient timeframes within the context of drug statistics. According to the Office of National Drug Control Policy, 31.5% of 12th graders use marijuana, which is down 33.6% from the previous year. On the other hand, the National Institute on Drug Abuse has reported that marijuana use among 12th graders has been down 18% since its peak in 1997. Both reports contain stark differences. The Office of National Drug Control Policy claims that a dip in marijuana use is almost twice as better as the claim put forth by the National Institute on Drug Abuse. On a closer examination of the actual data, you will see that during the period from 1975 to 2006, there are several peaks and valleys. You can tell a different story based on which time points of data you compare. This has become somewhat of an expectation in statistical reports on our drug war, in which critics often argue that federal officials selectively choose data that support their claims that their policies are effective. An analogy to this problem can be seen with stock prices for Apple. Depending on what time point you look at, you can tell a completely different story about the increasing or decreasing profitability of Apple. You can really choose whichever time point is most convenient for you to support your claim. A second example of the use of convenient time frames can be seen in the following statistic. Women are not interested in science and engineering. This report came from a Harvard professor and was reported by the Boston Globe. However, the report is highly dependent on the time frame that was selected. Whereas women were hardly seen in science and engineering fields before the 60s, the number of women entering medical school increased fivefold between the 1960s and 1980s, which was a period that saw not only tremendous gains in equality, but also the social acceptance of women pursuing science degrees. Once again, you can tell a drastically different story depending on the time frame you select. The third and final sampling problem discussed by Joel Bess is the use of selective comparisons. Unlike misleading samples, which refers to problems with how or where sampling is taking place, and convenient time frames, which refer to problems with when sampling is taking place, selective comparisons refer to problems with who or what the samples are being compared to. Use of the wrong comparison group can give an exaggerated sense of the problem's importance. The problem can be seen in the following statistics. Heart disease is the leading cause of death in the U.S. Both heart disease and cancer are often cited as the leading causes of death in the United States. However, heart disease is fairly uncommon among young people. In fact, the number one cause of death among college-age adults are accidents as opposed to natural causes. This statistic on heart disease being the leading cause of death in the U.S. is based on rates from a particular group of older adults that, when compared to younger adults, seems larger by comparison. The final example I'll discuss relates to the following statistic. Hot dogs are a major cause of cancer. This statistic was discussed in a report from CNN, which explained that the nitrites in processed meats causes a link to cancer. The interpretation of this statistic is really dependent on the group of foods that hot dogs are being compared to. Whereas our intake of nitrites might be higher in hot dogs than most other foods we consume, it is actually less when compared to vegetables. In fact, we get 90% of our intake of nitrites from vegetables, and there hasn't been much warning on vegetables giving us cancer. There are other issues here about the over-reliance on statistical and not practical significance relating to the size of the effect. However, we'll discuss this later in the course. For now, let's focus on the fact that, similar to the previous example, the use of a different comparison group can change the interpretation of the results that should be presented. Let's quickly recap some of the things you learned in this lesson. What sampling bias could occur if I asked you, is Britney Spears a great singer? You might say yes if you're comparing her to your own rendition of Hit Me Baby One More Time, but you might say no when comparing her to Pavarotti. This would be an example of selective comparison. What sampling bias could occur if I asked you, do Florida State football games rock? Well, assuming you bleed blue and white, you would be a non-representative or misleading sample. I'd be sure to get a different answer from someone who grew up in Seminole County. Finally, what sampling bias could occur if I asked you about the race and gender of Michael Jackson? This is an old joke, but most people would say that it would depend on the time frame you look at, early 80s versus late 90s. Hopefully, this helps you to better differentiate among these three types of sampling problems. Be sure to keep these in mind the next time you pick up a statistical report.